Okay, today we will discuss one problem which was appeared in NET 2019 and question number 36, and the subject code of the question is code is A. So here the problem is like that. So this is the differential equation is given. So we have to find out the solution of this differential equation. So this is a first order differential equation. So this is a first order differential equation, and we know that if there is a first order differential equations, there is a two general way to solve the first order differential equation. One is that we have to find out the integrating factor, and the other way that variable separable method. So generally, if this equations is in this form, like the general form, something like that, dy dx p of x, okay, and the q of x. If the equation is in this general form, then generally we use integrating factor method. So in this method, what we have to first find out the integrating factor, then we have to multiply the integrating factor over all over the equation, and then we will try to write down this differential left hand side of this differential equation as a total derivative. Then we can solve in this way. Let's see how we can solve this one. So now make this equation to reduce this equation to the general form. So now this equation will be something like that: x plus 1 divided by x y is equal to e to the power minus x. And we know the formula of the integrating factor, that we can calculate the integrating factor by e to the power p dx. What is p? The p is this is the p. So that means integration over 1 plus x by x into dx. So that means integration over 1 over x plus integration over dx. So it is e to the power ln x plus x, and it will be something like that, x into e to the power x. Now this is our integrating factor. Now we have to multiply this integrating factor over this all over these equations. So this equation became, now this reduced equation became x e to the power x dy by dx plus x, that means this is x plus 1 e to the power x times y, and if I multiply this integrating factor, the right hand side will be 1. Now I can try to write this part as a total derivative, something like that, d by dx of x into e to the power x into y. Let's see, if I take the derivative of these things e x y, then it will be, first term will be x e to the power x into y, second term will be x e to the power x y, and the third term will be x e to the power x y. So this will be something like that. If I take common e to the power x y, sorry, this one is dy by dx. So dy by dx. So if I take this e to the power x times y common, so it will be 1 plus x into e to the power x dy by dx. So now look at this term. So this is exactly the same term. So we can write this term as a total derivative d by dx of x e to the power x into y, which is 1. So now the take integration on the both these sides. Okay, now to take the integration on the both these sides. So the left hand side will be x e to the power x y, and the right hand side will be integration of 1 which is x, and there is a constant of integration, that is c. Now we have to find out what is this constant of integration. So we have to put these boundary conditions to find out the constant of integration. So that means when x equal to 1, y equal to 0. So if I put x equal to 1, so c, that is 1 plus c equal to 0, that means c equal to minus 1. So y, which is the solution, becomes x minus 1 by x into e to the power minus x. So now the solution is this one, and if you see that the first option is the right option.